Okay, this is a review of how to graph exponential and or logarithmic equations using transformations instead of using our graphing calculator. And essentially, the way we do this is the two steps that you see on the slide above. Is the first step is you have to decide what the basic shape is, and the basic shape is determined by what type of function it is, whether it's exponential or logarithmic, and what the base is, the base of the exponent or the base of the logarithm. The second step is then identifying what the transformations are in the equation, and we use those transformations to slide the graph perhaps left, right, up or down, flip it maybe over the x-axis or the y-axis, or stretch or shrink the basic shape. So the first thing that I want to focus on, which was some of our most difficult concept, was to decide what the basic shape is. So I'm going to review that, and we're going to start with exponential functions. And exponential functions, as we know, means that you have a base raised to a variable exponent. So it's going to look like f of x is b to the x. Now, the first basic shape is if the base is greater than 1. If the base is greater than 1, that means the graph is going to be an increasing or an exponential growth. It is increasing or it's a growth function. Okay, now the other thing is that all exponential functions, the basic shapes, have a y-intercept. It goes through 0, 1 because any base to the 0 power is 1. Okay, and the x-axis is the horizontal asymptote. Now, recall that what it means to be a horizontal asymptote is that it shapes the graph. Okay, so I'm going to draw the graph in blue so we can see it maybe a little bit better. Okay, the first thing is it's going to go through 0, 1, so it's going to go through here. And I'll do the x-axis, the asymptote maybe in red. Let's do that in red. The asymptote is the x-axis, so it goes across here. And then the function itself is increasing throughout its domain. It's this growth function. So the graph, and the asymptote kind of shapes it, so it's almost horizontal down at this end, and then it grows increasingly more and more after 0. More obvious after 0, I should say. So that is the basic shape and I'll give you several examples of functions that have that basic shape. For example, f of x is 2 to the x, looks like that. Or maybe f of x is 3.7 to the x. Or one that we've talked about, f of x is e to the x. It has a graph like that because e is 2.718 approximately. Okay, so any exponential function where the variable's in the exponent that has a base that's greater than 1 will start off looking like the graph you see right there. Now, on the other hand, if you have f of x is b to the x, and the base is between 0 and 1. Usually we just say base is less than 1. Everything else is the same, except for that it is decreasing, so it's a decay function. Okay, so this is decreasing, which means it's decaying. It still goes through 0, 1, and that's the point that we're going to use to do our shifting and our flipping, because that's the one that we know, and it still is the x-axis is the horizontal asymptote. Okay, so the graph looks very similar except it's decreasing. So if I were to graph that, let's go ahead and do the asymptote. Okay, so the asymptote I'm going to do in red, and we dash it because it's not really part of the graph. It's just kind of like an imaginary boundary. The graph itself goes through 0, 1, and it's going to decrease. And it's going to level off using the asymptote. The asymptote kind of shapes the graph. Okay? So those two are the basic shapes for all exponential functions that are being raised to the exponent power of x. Now, as far as logarithms go, logarithmic functions, they also have two basic shapes. And once again, it depends on the base of the logarithm. So if you have log base b of x, and the base is greater than 1, then it's going to be an increasing function. Okay? But this time, because we're talking about logs, which are the inverse of the exponential function, these graphs go through the point 1, 0. Now, it's not really the vertex. It's not because it doesn't really have a vertex, but you can consider it similar to something like the vertex. And instead of the x-axis being an asymptote, the y-axis is the vertical. It doesn't have a horizontal asymptote. It has a vertical asymptote. Okay, so I'll draw the asymptote first. Again, I'll draw it in red. It might be easier to do it by hand. So I'll just dash it down the y-axis. This is our asymptote. And this graph, because it's a log graph, which like I said is the inverse of the exponential, goes through 1, 0, and it increases, and the asymptote shapes it down here, and then it starts to increase beyond that. Okay? Now, the only difference is if the base is less than 1, it's decreasing again. So if I have f of x is log base b of x, and the base is less than 1, it is decreasing, but it still has the asymptote. So let me put that information down here. The only difference is now it's decreasing. So it's all based on that base. It still goes through 1, 0, and it still has the y-axis as the vertical asymptote. Okay, so if I were to graph that, the asymptote is still the y-axis. Let's get the right tool here. In the right color. There's my asymptote, and it goes through 1, 0, but this time it runs next to the asymptote up there, and then it decreases. Okay, so it's doing that kind of shape. Okay, so your first thing that you have to do when you're graphing any exponential or log function is decide which of these 4 graphs do we start with. Okay, so let's take this and now apply some transformations to it. Let's take the graph. Let's graph f of x is 1/2 to the x plus 2. And I'll go ahead and put that 1/2 in parentheses. Okay. Now, so the first thing you should notice is that this is an exponential function. Okay, and the reason it's an exponential function is because the variable is in the exponent. Okay, now, so we know that the graph is going to be one of these two, oops, not one of those two, one of those two graphs, because it's an exponential function. Okay, now, how do we decide which of those two graphs it is? Well, it's based on the base. The base is 1/2, which is less than 0. Not less than 0. It's not less than 0. It's less than 1. 1/2 is less than 1. So because it's less than 1, that is your decay or decreasing exponential function. So we're going to start, and I wonder if I can copy all that. I bet I can. We're going to start with this function, the decay function, right here, because that's our basic shape. And I'm going to see if I can't copy all that and move it to the new page. Let's draw. So this is what we're starting with. Okay, it's a decay function. Now, the +2 that's being added in the original function here, because it is not in the exponent with x, that moves the graph up 2. So this point right here that we have at 0, 1 is going to go up 1, 2, and now we'll be at 0, 3. That's not a guess, that is the actual graph. So really, I'm going to take this graph, let's see if I can take that graph and drag it up. I'm just going to drag it up 2. There's where we are now. It was through 0, 1, there's where we are now. Now the asymptote moves up 2 as well. Okay, so when I want to draw that, the asymptote, which is horizontal, it's going to move up 2 as well, and I'll do that in green so you can see the difference. The asymptote is going to move up 2 as well. So the new asymptote is now at y equals 2 instead of y equals 0. I said 2 root 0. Okay? And that's the graph of that exponential function. Alright, let's take a look at another type of function, and let's draw the graph of that. Let's graph let's take a look at this one, f of x equals 6 plus log base 2 of x. Okay? Now, this is a logarithmic function. And for obvious reasons, I mean, it has the word log in it. So this is a logarithmic function. So that means the graph of this is going to be one of these two graphs, because it's a logarithmic function. Now, how do we determine which graph it is? It's based on the base. So let's go back and take a look at the base of the logarithm. The base of the logarithm is base 2. And since that's greater than 1, it's going to be increasing. So it's the increasing log graph. So I'm going to go back and see if I can't copy that over. So we're looking at this one here, because that is the increasing graph because the base is greater than 1. So I'm going to try to, oops. Copy some of that. And move it to the next page. Quite where I wanted it, but it's okay. We'll take it. That is the basic shape. And that's your first goal, is to start by knowing what the basic shape is. Now, this graph has a 6 in front of it. Again, what's going to happen there is that 6 is going to cause the graph to go up 6 because it is not being grouped with the x. So it moves up 6 along the x-axis. So what I'm going to do is I'm going to drag this point here up 6. So it's at 1, 0. We're going to go up 1, 2, 3, 4, 5, 6. So we should be at 1, 6. And let's see if I can't just drag that up to 1/6. Now, when you move a vertical asymptote up 6, like if I were to take this and move it up 6, say this piece right down here, move it up 6, it's still on the same vertical asymptote. So the vertical asymptote doesn't move. On log graphs, the vertical asymptote only moves if you move left and right. On exponential graphs, they only move if you go up or down, because it has to do with the nature of the asymptote itself. Okay? All right, let's take a look at another one. Let's graph. Add a little something to it. F of x is, let's see, 3 to the x minus 1 plus 4. Okay? All right. So this is, the first thing you have to do is decide what type of function is and what the basic graph is. This is an exponential function because it is the variables in the exponent. Okay, and now we decide which of the two exponential functions we have based on the base. The base here is 3, which is greater than 1, so it's going to be increasing. Okay, so I'm going to start, let's see if I can't, I'm going to insert a blank graph this time. Just a wee bit bigger. There we go. Okay, so now I'm going to draw the basic graph in all blue. Okay, the basic graph goes through 0, 1 and increases like so. That's your basic exponential growth function. And the asymptote is here in the red. It is the x-axis. Okay? Now, the other parts of the graph are going to change. Some of these are going to change because the minus 1 is actually grouped in the exponent with x. That's going to cause it to go right 1. And the 4 that's not grouped with the x is going to cause it to go up 4. So the only point that we know the basic shape goes through is 0, 1. So we will drag that one. I'm going to draw it in green. We're going to go take that point and go right 1, and then we're going to go up 4, which will take us to 5. Okay? So my new point will be here at 1, 5. And the general rule of thumb is that the asymptote is going to typically be 1 unit below. But if you think about it, if I take this, I'm going to draw it in red, totally in red. If I take that red line and move it up 4, if I move it right 1, watch what happens when I move it right 1. Just drag it right 1. It's the same thing, it's just been moved to the right 1. But if I move it up 4, I go up 1. And then I drag it up again, I go up 2, I'm here, and then I go up 3, here, and then I go up 4, so your asymptote is going to be there in the red, and the final graph goes through that green point, is going to look like this. Okay? So the final graph is that green graph with the red solid asymptote up under it. Now, asymptotes aren't typically solid, but I just wanted to draw it so I could drag it a little bit better. Okay? All right, let's take a look at one more example. Let's graph f of x is negative log of, let's do x plus 5. Okay? All right. So we can see from the log that this is a logarithmic function. Now, this one is written log, and it does not have a base. So the base here is understood to be 10. It's a common logarithm. So that means it's increasing because it's greater than 1. So I'm going to draw the basic shape first, which might be the best thing you can do, even if you have to dash it. Alright. Okay, so I'm going to draw the basic shape. The basic shape of all log graphs goes through 1, 0. And this one's increasing, and I'm going to draw the axis once again in red, and I'm going to draw it solid. So the asymptote, the asymptote is going to be in red, and the basic shape of the log graph runs right next to it. That's what the asymptote happens. That's what it does, is it kind of shapes the graph over there, and then it goes to increasing. Now that's the basic shape. This actually is log of x, just plain old log of x, log base 10 of x. Okay? Now, there's two things that's going on in this example. The plus 5 that is grouped in parentheses with x is going to make it go left 5. And then the minus flips it over the x-axis. Okay? So, and we're going to follow the order of operations. We're going to move it left 5 first. In fact, I'm just going to drag these. Okay, so the asymptote is going to move left 1, then 2, then 3, then 4, then 5. So your asymptote now is at -5. Okay, and then I'm going to take this point here that goes through 1, 0, and I'm going to drag it 1, 2, 3, 4, 5. So it's going to be 1 to the right of that. So it's going to be at -4. So I'm going to take that graph, and I'm going to drag the whole graph 1, 2, 3, 4, 5 spaces to the left. Let me move the dot. Oops. See if I can't. I don't know if I can get the dot by itself. So we'll just assume the dot went with it. The dot was where it used to be. Okay, now that's the graph being moved left 5. But now we still have to flip it over the x-axis. So what it does when you flip it over the x-axis is instead of being increasing, it now goes the opposite direction and goes decreasing. So it's going to do this. Whoa. That didn't work out very well. Let's try that again. It's going to go down like this and go that way. And as you can see, it's the same thing, just been flipped over the x-axis.